Hello, friends. Let's start with the next topic, that is peer to peer process. At the physical layer, communication is direct. As you all can see in the figure, that device A sends a stream of bits to this device B through the intermediate nodes. At the higher layers, however, communication must move down through the layers on device A over to device B and the backup through the layers. Each layer in the sending device adds its own information to the message it receives from the layer just above it and passes the whole package to the layer just below it. At layer 1, the entire package is converted to a form that can be transmitted to the receiving device. At the receiving machine, the message is unwrapped layer by layer, with each process receiving and removing the data meant for it. For example, layer 2 removes the data meant for it, then passes the rest to layer 3. Layer 3 then removes the data meant for it and passes the rest to layer 4, and so on. Interfaces between the layers. The passing of the data and network information down through the layers of the sending device and backup through the layers of the receiving device is made possible by an interface between each pair of adjacent layers. Each interface defines the information and services a layer must provide for the layer above it. Well-defined interfaces and layer functions provide modularity to a network. As long as a layer provides the expected services to the layers above it, the specific implementation of its functions can be modified or replaced without requiring changes to the surrounding layers. Organization of the layers. The seven layers can be thought of as belonging to three subgroups: Layer 1, Layer 2, and Layer 3. Physical, data link, and network are the network supported layers. They deal with the physical aspects of moving data from one device to another, such as electrical specifications, physical connections, physical addressing, and transport timing and reliability. Layers 5, 6, and 7, session presentation and application, can be thought of as the user support layers. They allow interoperability among the unrelated software systems. Layer 4, the transport layer, links the two subgroups and ensures that what the lower layers have transmitted is in a form that the upper layers can use. The upper OSI layers are almost always implemented in software. Lower layers are a combination of hardware and software, except for the physical layer, which is mostly hardware. In figure 2.4, which gives an overall view of the OSI layers, D7 means the data unit at layer 7. D6 means the data unit at layer 6, and so on. The process starts at layer 7, the application layer, then moves from layer to layer in descending sequential order. At each layer, a header or possibly a trailer can be added to the data until commonly the trailer is added only at layer 2. When the formatted data unit passes through the physical layer, layer 1, it is changed into an electromagnetic signal and transported along a physical link. Upon reaching its destination, the signal passes into layer 1 and is transformed back into the digital form. The data units then move back up through the OSI layers. As each block of data reaches the next higher layer, the headers and trailers attached to it at the corresponding sending layer are removed and actions appropriated to that layer are taken. By the time it reaches layer 7, the message is again in a form appropriate to the application and is made available to the recipient. The next concept is of an encapsulation. Figure 2.4 reveals the another aspect of data communications in the OSI model, that is encapsulation. A packet, header and data at level 7 is encapsulated in a packet at level 6. The whole packet at level 6 is encapsulated in a packet at level 5 and so on. In other words, the data portion of a packet at level n-1 carries the whole packet data and header and may be trailer from level n. The concept is called encapsulation. Level n-1 is not aware of which part of the encapsulated packet is data and which part is the header or trailer. For level n-1, the whole packet coming from level n is treated as one integral unit. Let's start with the layers in the OSI model. In this section, we briefly describe the functions of each layer in the OSI model. Physical layer. The physical layer coordinates the functions required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. It also defines the procedures and functions that physical devices and interfaces have to perform for transmission to occur. The next figure shows the position of the physical layer with respect to the transmission medium and the data link layer. The physical layer is responsible for the movements of the individual bits from one hop node to the next. The physical layer is also concerned with the following: physical characteristics of interfaces and medium. The physical layer defines the characteristics of the interface between the devices and the transmission medium. It also defines the type of transmission medium. Second function of the physical layer is the representation of bits. The physical layer data consists of a stream of bits, a sequence of zeros or ones with no interpretation. To be transmitted, bits must be encoded into signals, electrical or optical. The physical layer defines the type of encoding, how zeros and ones are changed to signals. Next function of the physical layer is the data rate. Next is the synchronization of bits, is line configuration, physical topology, and the transmission medium. In coming classes, we will be looking in the topic of transmission medium into more detail. So let's dive into the next function of physical layer, that is data rate. The transmission rate, the number of bits sent each second, is also defined by the physical layer. In other words, the physical layer defines the duration of a bit, which is how long it lasts. Synchronization of bits. The sender and receiver not only must use the same bit rate but also must be synchronized at the bit level. In other words, the sender and the receiver clocks must be synchronized. So here we stop with this session. We will continue in the next session and we will start with the data link.